Today we are going to look at solving one-step inequalities. So the first thing we need to understand is what an inequality is. So hopefully at this point we have seen these four symbols and we know the words that we associate with them. Right? So the idea that we need to introduce is that if we have something like x is greater than 3, right, this means x can be any number that is greater than 3. So 4, 5, 6, 7, but it also could be 4.1, 4.2, 4.22, 4.222. Right? There is an infinite number. There are so many numbers we cannot write them down of numbers that are greater than 3. So instead of us trying to write down all the numbers that are greater than 3, we represent all the numbers that are greater than 3 on a number line. So for example, I want to graph x is greater than 3. We're going to put 3 numbers each time on our number line, where 3 is going to go in the middle, and we're going to have a number to the left and a number to the right, right? So I'm just counting in order, 2, 3, 4. Okay, now this inequality says x is greater than 3. X cannot be 3. So if x cannot be 3, I'm going to put an open circle there, right? That means I can get as close to 3 as I want. I can be 3.1, I can be 3.01, I can be 3.001. I just can't be 3. And then I'm going to shade all the numbers that are greater than 3, right? 4 is greater than 3, 5 is greater than 3. And if you're unsure which direction to shade, you can always draw a line in here and make this inequality sign look like an arrow, and it will point to which way you should shade. Okay, so if we look at our second one, all right, I have -2. Now be careful, negative number lines feel a little bit backwards. They're not, but they feel a little bit backwards. So this one is saying x is less than -2. It's not equal to, so it cannot be -2. So again, that gives us our open circle. And we want numbers that are less than -2, which are going to be numbers to the left. And again, if I draw my line in here, right, that's going to point to the left. It's going to make an arrow to the left to show us where our shading goes. On this third one, now we introduce the idea of it being or equal to, right? So this is greater than or equal to. So I'm still going to put my -12 in the middle. And again, I'm going to be really careful with the order of my number line. Okay, but this one says that x can be equal to -12. So at -12, I'm going to put a solid circle. That solid circle means that -12 is an answer. I could pick -12. Okay, and then again, my shading, right? I want numbers that are greater than. If I draw that arrow in there, I'm going to shade to the right. And for less than or equal to, right, I want 7 on my number line. This is going to be a solid circle at 7. Because it is included, right? It is or equal to. A solid line underneath is a solid circle when we graph it. And then I want numbers less than, which means they go to the left. Now, we can still solve inequalities. We solve inequalities just like we solve equations. We just can also graph their answers because they have an infinite number of solutions. So I'm still going to make my line here. I'm just making it at the inequality sign instead of at an equal sign. I'm going to identify my variable, and I'm going to look and see what sign is in between the x and the 7. So in between the x and the 7 is addition, right? Addition and subtraction means to look in front of the 7. So in front of the 7 is that addition, so I'm going to undo that with subtraction. My 7s cancel. I'm going to bring down my inequality sign. So instead of bringing down an equal sign, I'm bringing down an inequality sign. And I'm going to get x is less than or equal to 5. Right? So the difference is that I can now graph this on a number line where I'm putting my 3 numbers. And then I'm looking at my sign, right? This was less than or equal to. Or equal to means a solid circle. And I'm going to shade this to the left. So I look at my next one. I'm going to draw my line. I'm going to find my variable. Right? I'm looking in between the z and the 12. In between the z and the 12 is subtraction, which means I need to look in front. Addition and subtraction always tells me to look in front. To undo subtraction, I use addition. These cancel. I'm going to bring down my inequality sign, and I'll get z is greater than 10. And so if I go to graph this, a greater than does not have an or equal to, so that's an open circle. And greater than means I'm shading to the right. So number 3, I'm drawing my line. I'm identifying my variable, right? In between the z and 5, I see division. Remember, at fraction bar is division. And I undo division with multiplication. So I'm going to multiply both sides by 5. Those 5s cancel out. 12 times 5 gives me 60. Just bringing my inequality sign straight down. Make my number line. Oh, I forgot my or equal to, right? Be really careful because it's easy to make that mistake, right? I just did it. So this is an or equal to, which means I am going to fill this in. It can be 60. And then I want numbers greater than that, which go to the right. Okay, next one here, I'm going to draw my line. Find my variable. If I look in between 2 and x, I see addition. Addition and subtraction always tells us to look in front. So in front of that 2, I see a negative, so I'm going to undo that with a positive, right? The positive is the same thing as addition. My inequality sign comes straight down. So I'm going to make my number line. Right, -2 in the middle. Be really careful with your number line. -3 goes to the left. This does not have an or equal to, so that's going to be an open circle. And less than means we shade to the left. Okay, so that's our general rule. There's one other thing that can happen, for at least for right now, that we're going to look at. That's a little bit tricky that we need to make sure we take care of. Okay, and this is going to look the same to start. We draw our line. That seems normal, right? I'm finding my variable. I'm looking in between, so I'm focusing on this side because my variable's on the right. So in between, I see addition and subtraction, so I look in front. I'm going to undo that, subtracting 2 by adding 2. I need these things to fall straight down, just like we've been doing. They have to fall straight down. So 14 plus 2 is 16. My inequality sign is coming straight down, and my x is what's left over here. Okay, the key is that just like we talked about with equations, right, we want that x first. That's the better way to write this. The thing is that we just can't write it with the x on the other side and just switch places like we can with an equal sign. So what we need to do is we need to switch the x and the 16, which is fine. I'm going to bring my x over here and my 16 over here. But when that happens, the inequality sign has to flip directions, right? I'm changing the way that it opens. So this now says x is less than or equal to 16. So that when I go to graph this on my number line, right, I still have that filled in circle because it's or equal to, but this is what I need to shade. And so I'm shading to the left, right? I don't want to know how 16 relates to x. I want to know what x is to 16. So we always want that variable first. So look at number 6, right? We start out normal. We draw our line. In between 4 and y, we see nothing. Nothing means multiplication, so we're going to undo multiplication with division. Everything is coming straight down. But again, I don't want my y second. So if I rewrite this, I'm flipping my 3 and my y, and then I'm changing the direction of my inequality sign. So now when I go to graph this, all right, this is going to be an open circle, and I'm going to shade this to the right.